Good day, grade 11s. Welcome to another video. So today's lesson focuses on Euclidean geometry. So with me, I've got an extract from a previous question paper. This is a 2019 Northwest June examination paper 2 mathematics. So let's do this question together. So it says in the diagram, O is the center of the circle, Kj is equals to JL, and K is equals to 50 degrees. So line KJ is equals to line JL. Those line segments are the same. O is the center of the circle, and we given angle K to be 50 degrees. So let's move over to the questions. It says 6.1, determine giving reasons the value of angle MOL. So let's identify angle MOL. So angle MOL on the diagram is given as this angle here. So this is the angle of interest that we're looking for. To find this angle, we need to take note of the following chord, that is ML. And we need to notice that ML subtends an angle at K, a point on the circumference, and the very same chord subtends an angle at O, a point at the center of the circle. If you look at it in this direction, so we can relate the angle subtended at a point on the circumference to the angle at the center, subtended by the same chord. So the angle at the center should be twice the size to that of the angle at a point on the circumference if both angles are subtended by the same chord. So let's write this down real quick. So we can say angle MOL is equals to 2 times angle K, and the reason is angle at the center is 2 times the angle at the circumference. So we can substitute 2 times K is 50 degrees. So this is equals to 100 degrees. So moving along to the next question, they want us to find the size of angle N, and we need to provide reasons. Let's identify angle N. So angle N on the sketch is this angle here. So we need to find the size of this angle. In order for us to find the size of this angle, we should consider triangle NKJ. We need to consider this triangle. You will note that we have angle K to be 50 degrees. This is the angle of interest, angle N, and we can determine angle J1. Let's start off by identifying or determining the size of angle J1. So if you consider the line drawn from the center to point J, the midpoint of the chord KL, the angle that forms between line segment OJ and the chord KL is 90 degrees. So J1 is 90 degrees. So all this can be written as Kj is equals to JL. That's given. So this means that angle J1 is equals to 90 degrees. And the reason is line drawn from center to the midpoint of the chord. So now we can make use of sum of interior angles of a triangle to find the size of N. We can say angle K plus angle J1 plus angle N is equals to 180 degrees. And the reason is sum of angles in a triangle. So now we can substitute angle K is 50 degrees. plus angle J1 is 90 degrees plus angle N is equals to 180 degrees. So now we can solve for N. So this implies that angle N here should be equals to 180 degrees minus 90 degrees minus 50 degrees, and this is equals to 40 degrees. So we can note this down on the diagram that angle N is 40 degrees. So moving on to the next question, they want us to find the size of angle L1. We need to provide reasons. So angle L1 is given as this angle on the diagram, which is angle L1. And in order for us to find L1, we need to consider triangle OLM. We need to consider this triangle. We found MOL to be 100 degrees. And what we can also note is that OM and OL are radii, so their lengths are equal. So it means L1 and M2 then become equal angles, because angles across equal sides are equal. So this angle is across this equal side, and this equal side is across this angle. So angles of opposite equal sides are equal. So we can just write this down quickly. We can start by saying that OL is equals to OM because of radii. Radii is the plural for radius. And now we can safely say that M2, angle M2 is equals to angle L1. And this is because angles opposite equal sides. Now we can make use of some of interior angles of a triangle. We can say angle MOL plus angle M2 plus angle L1 is equals to 180 degrees. But I'm going to rewrite this expression, this equation as MOL plus L1 plus L1 is equals to 180 degrees. So what I've done here is I've replaced M2 with L1. I've replaced M2 with L1 because we saw earlier on that M2 is equals to L1. So now we can make L1 subject to the formula. So this implies that MOL is 100 degrees. These two L1s is equals to 180 degrees. So therefore 2L1 is equals to 180 degrees minus 100 degrees. So therefore this implies that L1 should be equals to 80 degrees. So therefore L1 should be equals to 40 degrees. So we can just label L1 here as 40 degrees. So moving on to the next question, it is prove that MOLN is a cyclic quadrilateral. So let's identify MOLN on the sketch. So MOLN, we need to prove that this quadrilateral is cyclic. So there's a number of ways of proving that a quadrilateral is a cyclic quadrilateral. To mention a few, you can prove that interior opposite angles add up to 180 degrees. You can show that an exterior angle is equals to the interior opposite angle, or you can identify angles subtended by the same chord to be equal. And for us in this given case, if you have a look at MO as a chord, you'll notice that it subtends an angle at N, and it also, the same chord subtends an angle at L1. If you were to imagine MNLO to lie on a perfect circle, so we can say that MOLN is a cyclic quadrilateral since angle N is equals to angle L1, which is equals to 40 degrees. And the reason is the converse of angles in the same segment, since we are using the answer to prove that the quadrilateral is cyclic. Thanks for watching. See you in the next one.